All right, team, going over the answer now. Some of you guys have already gotten your answers checked off by me, so you're fine. All right, going over the answer. Okie dokie. So, first step in here, we've given you a molecular mass of something. So we said that you have weighed, or we have weighed out 2.57 grams of citric acid. It was added to a 250 volumetric flask, and we need to figure out what we have concentration-wise. But first thing we need to do is convert it from grams to moles, because we don't want to be working in grams, because grams just tell us the mass of a substance. It does not actually tell us the amount of the substance, and since we're talking chemistry, amount is really important, because then if we talk about amounts, we could talk about it in the equation. So we do need to convert this into moles. Remember, I will give you all equations. You don't have to worry about memorizing them. And the way for us to convert from mass to moles is to do m divided by big M. So my little m is this, because that's my mass. And my big M is this here. That's my molecular mass. So I'm taking 2.57 grams and dividing it by 210.14 grams per mole. I like to write my units down because it helps me then see to make sure I've done my things correctly, and so I know what units I need to be writing. So grams and grams will cancel out, and then I'm left with per mole per. So per mole, so that changes it to mole. So let's do that. 2.57 divided by 210.14, and I got that answer there. So my N value, I did not design that very well, 0.012229941 moles. Leave your answers nice and long until they say to do some rounding. If they don't do some rounding, then don't worry about it. All right, people that requested part B to be printed, here you go. There's 2 pages. 2 pages. I thought I double-sided it, but apparently not. So, 2 pages. And I can print you guys some more next lesson. Yeah. I thought I was going to print double-sided and it didn't. Which makes me sad. Just 2 pages. It's not double-sided because I forgot to hit the double-side button. Yes. I mean the one from before. No, I did a wholly different question for practice. It's the same style of questions. I swapped it around. Do you see do you see it now? It's not the same question. I changed the numbers and I've changed the equations. Yeah? I got 4 practice questions. All right. Next thing I need to do then is figure out the concentration. Again, I give you guys the equations. So, concentration equals N divided by V. N I solved in question number 1, so that's where I'm getting my N from. And the V I'm getting from up here, because that's my volume. Okay? So N is equal to the answer before, 0.012229941 moles. And then I'm dividing it by my volume. Be mindful, volume needs to be in liters because we talk about things as moles per liter. So we need to convert any milliliters to liters. So since that's 250 milliliters, then there's 1,000 mils in a liter, I divide it by 1,000. So 0.250 liters. All right, so I take that number and divide it by 0.250. All right, always keep things in your calculator so you don't have to retype all the numbers. All right, there we go. 0.4, blah, 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 blah. So most of you guys are fine. You're getting up to this point without an issue. Good? 0. All right. Next thing then is I need to figure out the amount of acid that would have been in my flask when I'm doing my experiment. So when I think about that, and you think about, again, the volume. In this case, we're doing a different volume because we're talking about taking a 25 mil sample. The other issue is that this equation is in the wrong order because I want to solve for n now. See, it tells me n. N equals C times V in this case. I will not give you rearranged equations. You are expected to do that yourself. So N equals the concentration I got in the last question. So basically question number 2. Isn't it great that the stuff that you did in the last question you use in the next question? How logical is that? Times volume. Remember, 25 milliliters converted into liters. 0.025 liters. And this is in moles per liter, because I want those liters to cancel out. So if you're not sure what unit to use, do stuff like that. I can see liters cancel out, so I take that answer, times it by 0.025, there we go. And now I get my number. It's to the negative 3, 1.222994194 times 10 to the negative 3 moles. Now, some people were asking me about this and how to convert this over into a decimal number without the exponent. So if this is negative 3, you move the decimal place over 1, 2, 3. Put the dot there, that's the 0. So it'd be 0.0012, yada, yada, yada. But don't need to do that. All right, next one. This is the one that's probably going to trip you guys up the most, and that is the conversion for the ratio. So what we're basically looking at is how much how much base do I need to neutralize that amount of acid? I look at the equation and I see what the number is in front. I see the number is no number, so that is 1. I look to see how much base there is, and it is 3. So that tells me I need 3 times as much base to neutralize all the acid that is there. If the numbers were flipped and this was 3 and this was 1, I would be dividing by 3 because it would say I need a third of base to neutralize my acid. All right, so watch these numbers. If this was a 2, you times by 2. So I take this number, and that's in mole. I times it by 3. It's still in mole. Take that number, times it by 3. Enter. And then that's a nice long number. It is 3.668982583 moles. Or sorry, times 10 to negative 3 moles. So that's how much base I need to neutralize my acid. We good? All right, keep going. Okay. It's watching our time. We got 5 minutes. Okay. This bit here, you need to do your subtractions. Most of you guys were fine with that subtraction bit. Oh, that one's easy because it's 0. So 24.26. That one's 24.01. This one here, 48.62 minus 24.62. All right, something to keep in mind, you should have 2 decimal places as numbers. These numbers are not actually the numbers you guys will be getting. Remember, your numbers are either going to end in a 0 or end in a 5. So those are my numbers. Next thing I need to check is it concordant? So when I want concordant data, I want it to be within 0.3 mils from the highest to the lowest. If I select non-concordant data, it will automatically limit you because part B and C are correlated together. In order to get excellence overall in this assessment, you need to get excellence on part A, excellence on part D, and you have to pass both part B and C perfectly. So that's excellence overall. If you do not use concordant data for this section here, this section gets marked to an achieve because concordant data is a merit requirement. The good news is you can still get merit overall because you can do concordant data in your part C. Okay, so you get 2 chances. But if you don't select concordant data for B and C, you're going to be stuck at achieved. So when I do the subtractions, this and this numbers do not work. It is 0.35. So you have a choice of either taking this number out or this number out. Both are correct. You're going to have slightly different numbers depending on which one you exclude. I personally excluded that one. because that one seemed to me further away because these were closer to the 3. Anyway, so we are going to average. So we add all 3 numbers together. And then I did something really weird. 24.26 plus 24.36 plus 24.29, and then divide it by 3. So I added these 3 numbers together. Just going to try to save time, and then I divide it by 3. Remember, if you're using all 4 data points, then you divide it by 4, because to average, you divide by the number of things you're adding together. This is 24.3 milliliters. Now, something I have to keep in mind with that answer is now I'm asking for 3 sig figs and I'm asking for units. So I'm doing 1, 2, 3 instead of the nice long number I have here. Okay? And then last step here is, again, using that C equals N divided by V equation. So the N I've gotten from question 4, the V I've gotten from question 5. Again, be careful with question 5. This needs to be converted into liters when you do the calculation down here. So I take my answer from my previous sheet. Whoopsie, sorry. 3.66 ... times 10 to the negative 3. I'm just trying to save us time. And then you divide it by 20 point... no. See, I made the mistake. Like that. That one's in moles. So now I get an answer in moles per liter, which is what I want. You should have gotten 0.151 moles per liter as your answer. This was actually 0.1509 ... We have to round up. So that 0, look at the 9, I round up. Anything 5 and higher, you round up. Anything 5 and lower, anything lower than 5, you round down. If you excluded this number instead, your answer would have been 0.152. So just a slightly different answer. Okay? That is the answer to that one there. So if you had done all this correctly, this one is definitely going to be the harder one because I will give you a non-1-to-1 ratio. On part C, I will give you a 1-to-1 ratio, so you don't have to worry about this one as much. All right, but I need to give you at least one question that is not a 1-to-1 ratio in order for the assessment itself to qualify for excellence. All right? So keep that in mind. This is now on track for excellence. For achieved, you just need to get basically one step of this calculation correct. Most people, it's this section here. So if you could do that calculation, you're at achieved. Yes. Okay? If you can just do this one, you're at an achieved. Great. Yes. All right. That's us.